Hi, I'm Tovar-Rabatte, and I'm going to explain how I would teach electromagnetic waves, which is TEAC 8.8C, part of Category 3 on Earth-based science for our 8th grade STAR test. We always want to make sure that we teach our supporting TEACs, since that scaffolds our power TEACs, or rather our readiness TEACs. The first day of this lesson, I would ensure that we have an interactive word wall and that my students have been introduced to the vocabulary. We've probably even used a My Dictionary page with the term, the definition, and a nonverbal memory tool, meaning a picture, so that our LEP population and our emerging readers have access to that vocabulary to build the foundation for their scientific literacy. Remember, all of our vocabulary, those are the bricks. We are working with our students to use the mortar to put the bricks together, then the wall, and then the house, which is the foundation of their science learning. As they come in on the second day, we're going to go to our interactive student notebooks. On the left-hand side is the student input. As they come in, will be their do now, geared towards our overall learning objective, which is how we use electromagnetic waves to learn about the properties of the universe. Students are going to draw the wave and label the crest, trough, amplitude, and wavelength, followed by drawing a wave with greater amplitude and then drawing a wave with greater frequency. I would give students approximately 3 to 5 minutes to do this, and then using my multi-response strategies, such as whipping around, I would call upon students randomly to see if they were able to answer. If they are not able to answer, I would choose another student, but I would go back, since I'm going to also integrate the no-op strategy, and call on my original student to repeat what the learning is to ensure that they know the answer as well. Moving from this, we're going to transition to our cooperative groups based upon learning styles. Students would transition, and we'd have music playing and a timer, and they would be working with their set of wave cards. In groups, students would need to align their wavelength with the type of wave, with the memory tool or image for that tool, along with what the wave is used for, and then what the penetration power is of that wave. This particular activity would probably take anywhere from 20 to 30 minutes, especially if students are also filling in an accompanying worksheet to help them pull all these ideas together to ensure that they remember that while we can be friends with Roy in terms of red, orange, yellow, we need to be more concerned about Mr. Biv on our blue, indigo, violet length or side of the spectrum. After this activity, I'm going to transition back to our interactive notebook, and on the teacher processing side, I'm going to give the students the notes, and I'm going to model annotated note-taking along with the Cornell question on the left-hand side. Students would spend approximately 10 minutes on this, and then we'd wrap up with our demonstration of learning, asking students how do astronomers use different wavelengths of the electromagnetic spectrum to learn about properties of the universe. At this point in time, I would expect students to be able to write a 1 to 2 sentence summary. I may provide a STEM if there are LEP students in the classroom needing that support. Moving on from this, we go on to other lab activities the following days, looking at the Doppler effect and looking at other free response questions, possibly some STEM scopes. My overall philosophy of science education is that it is our job as teachers to light the fire. We are the leaders in the classroom, the lead learner. Learning with your student is always critical. I want students to have equitable access so that they can do anything that they want to do. We need to have a classroom that increases scientific literacy, that increases reading aptitude, and that also involves lab resources. Teachers do need to take ownership over the process of helping administration build that base of lab equipment through educating our administrators and also looking outside the community. Students do want and deserve to do hand-on activities, and between the interactive notebook and lab activities, our students will be successful. Thank you.